so this question here looks quite straightforward, but there's a little bit of a red herring there along the way. So copy it down, have a go at it, and see if you can spot where some students might slip up. Identify the red herring. Press pause, have a go. Okay, so if you look at this question, there is something that jumps out to you that's obvious to do, no problems, and that's the left-hand side. Log 2 of something plus log 2 of something, you can multiply those together. So 32 times 16 is 512, so the left-hand side is log 2, 512, and for now I'm going to leave the right-hand side as it stands. Now, pause the video again if you have not identified the red herring. I'm about to reveal the red herring. So, here we go. It's over here. Now, the step that you must try to avoid to make is bringing this 2 down there. So if I bring that 2 down there, I'm basically saying that that is equivalent to that. Now we have a log law that says if there's a power, I can bring it down, except it doesn't apply here. Could you think why? Perhaps take a step to think about that. So, the red herring is that 2 is on the outside. The whole of log 2x is being squared. That's log 2x multiplied by another log 2x. If that squared was on the inside, i.e. the thing inside the log is being squared, then you could bring the 2 down. So if that 2 was over here, say, then you could bring that down like this. But it's not. It's on the outside. You have to be careful what the log law says that you're allowed to do. So we can't do that. So I need to rub this out. Now, if I'm not allowed to bring the 2 down, because the 2's over there, not there, well, let's ask a more important question. What am I able to do? So, in a case like this, it's actually quite simple. Think about where the unknown is. The unknown is x. Log 2, 512, that's just a number. That squared can be eliminated by square rooting both sides. So that's what we should do. Now, perhaps you identified that 512 is an exact power of 2. It's an exact power of 2. It's 2 to the power of 9 is 512. If you recognise that, you can also use the calculator. Ultimately, log 2, 512 is 9. So let's just simplify that. And once again, because I can't do anything with that 2, I cannot bring it down as we've previously mentioned, I don't really want to write this as log 2x times log 2x. You don't, in logarithmic equations, you don't want to increase the amount of logs you have. Ultimately, you want to get rid of the logs altogether, which is what we've been doing. It doesn't make sense to write log 2x times log 2x. It doesn't help you. So we have to get rid of the squared, which we can do by square rooting. Be careful. Square rooting 9 is plus and minus 3. So log 2x, I'll write it like this, use a square bracket for the 2 possible values, is plus 2 and minus 3. So let's deal with each of these values in turn. Use the definition of the log to get rid of the log altogether here. What is that x? 2 to the power of that is x. So we have x is 2 cubed, which is 8. That's one solution. And also 2 to the power of minus 3 is 1 over 8. That is the second solution. It is important when you square root to think of plus 3 and minus 3. You will lose one of the solutions and a lot of the marks towards the end. So be careful and watch out for that. Okay, so have a go at this question here. It says log 5 in brackets squared minus 7 log 5 in y in brackets plus 12 is equal to 0. It's not exactly the same as the previous example, but it uses the same ideas. So get that down, pause the video and have a go. Right, so hopefully we realise that, like I mentioned in the previous example, if log 5y, or log of something, is being squared, you cannot use the log rule. There's no way of getting rid of that too. So in fact, what we need to do here, because I've also got log 5y, I can't square root like I did in the previous example. What you need to hopefully realise, it's a combination of the previous examples that we've done. you've got log 5y that's being all squared, so I've got that issue, and I've also got the fact that log 5y is being squared, and there's a log 5y. That's the square of that. So it's a quadratic in disguise, and it's the whole log 5y business where I can't bring down the 2. So actually, what we do here is we use a substitution. U is log 5y, and you can see it's a nice quadratic, minus 7u plus 12, which factorizes very nicely. U minus 4, u minus 3, so u is 4, or u is 3. And now we bring this back in. Usually when you do a substitution, it's 2 to the power x or something like that. But now it's a log. That's fine. So let's do log 5y is equal to 4. Then reverse the definition of the log. So 5 to the power of 4 is y. So y is 5 to the power 4, which is 625. You need to do it for this as well. Log 5y is 3, so y is 5 cubed, and another solution is 125. So 125 and 625 are the solutions there.